So today I will be talking about Coolhunting and how we can use the power of prediction to identify trends from social media, on the web, on Twitter, on Facebook and on blogs. The overall framework of coins consists of three parts. It's the core part, creating the coins, the collaborative innovation networks, motivating and nurturing the creators that are the part of the original coin. The Coolhunting part, which we are going to cover today, which looks for the cool ideas from social media, and the virtual mirroring part, which helps the members of the coin to be more efficient. And today we talk about Coolhunting. Coolhunting has a few basic principles. Remember the distinction that we are making between the crowd and the swarm, the stupidity of the crowd and the smartness of the swarm are in contradiction, and we find the crowd mostly on Twitter. We find also experts on blogs, and we find members of the swarm on Wikipedia, on Facebook pages and in online forums. Of course, it's also possible to find swarms on Twitter, but for that you have to do more sophisticated filtering. Also, swarms make things cool and look for cool things, and crowds look for hot things. I make a distinction between hot and cool. Hot things can be bought by advertising. Cool things are intrinsically positioned inside the product. Other principles are the emotionality, and the more emotional the crowd gets about the product, the better for the product. And the network structure, which is a characteristic of the swarm, and if we find a very well-connected network of people, then that's a good predictor that we might have found our swarm. The principle of finding the cool ideas is that we are not looking for trends, we are looking for trendsetters. And then we measure the speed with which the trendsetters influence other people. The metric of influence, the key metric, is between centrality, which goes from 0 to 1 and measures the strength with which information flows through a network. We also measure the sentiment. Sentiment is measured through a bag of words approach, where we have positive words like good, great, wonderful, and we have negative words. And the bag of words can either be constructed manually by just reading through a document and marking positive and negative words with a light pen and then entering that into the computer. Or we can use a machine learning system where we classify entire documents. That could be tweets, that can be blog posts, that can be product ratings on Amazon, by their positivity or overall negativity, and then we let the computer find the most predictive words. And Condor is sophisticated. It has a machine learning module built in that finds those most emotional words. Let's now look at the different information spheres a little bit in more detail, because their characteristics are actually quite different. Twitter tells me what the crowd thinks right now, in this very moment. That means it doesn't really go much ahead. It doesn't really go back into the past. The crowd has no memory. Twitter has a memory. We can search it with Twitter search or with Topsy. The Twitter search API only goes back by about 8 days, but if we search for the Twitter streams of individual people, we can go back much farther, theoretically back to the beginning of when somebody joined Twitter. Twitterers, they are not tweeting really to innovate, but to show how great they are. They can tweet to find others like them. This is one of the key applications of Twitter. And we also need to be aware of the different national characteristics that people tweeting demonstrate. If we are doing an analysis in Latin America, in Malaysia, in the Philippines, in Mexico, Twitter is perfect. Everybody in those countries tweets, and people are using that for expressing their deepest thinking and sentiment and feelings. And you can think of Twitter users in those countries using Twitter to tell others about a break-off with their significant other. So if a girl breaks off with her boyfriend, she will tweet that. This is quite different in the US. US Twitter works, but it's more used among a relatively small group of people for marketing, for self-promoting ideas. And that means that for the innermost feelings of people, Twitter might not be the best. The relatively small percentage of people that are actual Twitterers, you can think of them like a probe into the soul of a country. And in that regard, they give you a view of what's going on in the US. In Europe, particularly in German-speaking countries, Germany, Sweden, Denmark, the Nordic countries also, Finland, Twitter is not very prominent. The only people that tweet there are marketing people and politicians. And so if you do a brand analysis in those countries, Twitter gives you only quite limited insights. Also, when you do look for product efficiencies with Twitter, for example, Twitter might not be the right place. Twitter is very good if somebody has been in Disneyland and is put off by an experience they have had with a Disneyland salesperson, or if I'm bounced at the airport, then people will tweet to vent their frustration. But they will not really use Twitter to complain about some long-term product deficiency feature of their car or their refrigerator and so on. It happens, but when we looked at tweets about cars, people were tweeting that their car was stolen. People were not tweeting that there was a color problem with the door of their car. Blogs show a very different profile. Bloggers share more complex ideas. Blogs are there to be found, to stay around, to never go away. In that respect, they are much better to find ideas that are there to stay. And because blogs are updated very frequently, like once per, every day, and Google blog search is very quick, minutes or even fractions of a minute in picking up changes to a blog. It's quite up to date too. It's newspapers that are sharing their news content through an RSS feed, so you will catch those. But you will also find patient blogs or product blogs or novelty blogs. So blogs are political blogs, and the results will be there to be found, and they are very good to identify long-term trends. Facebook is great for fanning the swarm. The main problem with Facebook is that it cannot be easily collected. We can only access the Facebook wall if the owner of the wall is either a friend of the person accessing it, or it's a public page. And in that regard, Facebook is very limited. And what we can get is the Facebook network of individual people, and we also get the likes of those people, but what people are saying, that cannot be extracted easily. There are ways of getting access to some Facebook pages. You can, for example, just paste all the text of a Facebook page into Word and then construct a word cloud using Wordle or something else. But you cannot really get a complex network structure out easily. The same, by the way, also goes for online forums, which are another great source for finding the swarm that, for example, cares about plumbing, that cares about skiing, that cares about chronic diseases, and so on. But in order to do such an analysis, one needs to team up with the owner of such a forum, with the owner of such a Facebook page, and then we can do an analysis and find very surprising insights about what's going on a Facebook page about a certain topic, brand, cause, and so on. Finally, Wikipedia. Wikipedia is a great source of most recent events. We have built a system called SwarmPulse, which is as fast as any newspaper. It basically takes the most recent edits and it weighs them by the importance of the people doing the edits, and it thus shows me all the trends that are currently happening. And in that regard, it's another great way of finding last minute development. There is discussion about whether there is some more leftist liberal slant of the people editing Wikipedia, but research has found that this, if the effect exists, it's very small, because also the more right-wing people have by now understood the importance of Wikipedia, and so they are publishing their content, updating it very frequently also. So before we now look at more in-depth findings and how to use Condor for doing such an analysis, a few general recommendations up front. The entire purpose of this marketing analysis, brand analysis, is to create communities using the cool hunting insights for cool farming, using the cool ideas by approaching the people that have developed those cool ideas, which means finding the role models. And we will see how we can do that by looking at Facebook profiles and by looking at the retweet rate of tweets. So if Justin Bieber tweets, his tweets will be retweeted by thousands in seconds. If Peter tweets, nobody retweets, and it takes very few people will retweet, and it will take them a long time. So again, the same metrics as we have found them before, the same 6 honest signals apply here also for tweets, for blogs, for Wikipedia edits. It pays to blog. So if there is one insight, it's that if you have a cause, if you are trying to raise awareness for a certain brand, product, topic, then maintaining a blog is a must. But also making sure that the Wikipedia page accurately reflects what you are saying by editing it and making sure that it is linked in the right ways is quite important. It's not appropriate that you do your own Wikipedia page. A person is not supposed to edit their own Wikipedia page, and a vendor is not supposed to edit their own brand page, and Wikipedia editors are quite quick in catching those violations. But make sure that you have a community that edits your causes, your brands, your pages. And once we have those sources, once we have the Twitter networks, blog networks, Wikipedia pages, we can identify those people and can work with them to curate and develop a user community. One big advantage of our approach is that there is a very straightforward, offers a very straightforward way of constantly tracking how efficient a branding campaign is by measuring the impact of Twitter, the impact of Facebook, not just by likes, because getting many Facebook likes that can be bought, and getting many tweets that can also be bought by just paying people to retweet what you are saying. But if you construct a retweet network of the people retweeting your tweet, you will see whether you have had real impact or not. So now let's go to Twitter. And here we see an example of Twitter. This is from a real project where we have looked at the tweets about different car brands over 3 months globally and in different select markets in the US, in Germany, in the UK. And we can use such a Twitter network in 2 ways. First, we construct a bipartite graph, which means you have 2 types of nodes. So the circles you see here, for example, the green circles about the BMW i3, they are all about Twitterers. So each circle is a person, except the biggest circle in the center, which is the car brand itself, and all the tweets originating from that brand. And by measuring the betweenness of that big fat actor, the biggest here is the Chevy Volt, we will be able to measure how important this brand is in the Twitter sphere. And at the right, you see a visualization of that result, and this has been done by just exporting the actor betweenness centrality to Excel, and then visualizing that chart right in Excel. We can use the same export file, not just to measure and compare the strength of brands, but also to measure and compare who the most important Twitterers are. In this case, what we find, the real Autoblog has the highest betweenness centrality, somewhere above 0.015. And it also turns out that all of those most important Twitterers are journalists and bloggers. But remember, the analysis that we have looked at before, the network that you see here, has been used to produce the chart at right, the donut chart to show the importance of the brand. And then it has also been used by measuring the same betweenness, but not of the brand, but of the individual Twitterer, of the actor in the language of social network analysis, to measure how important they are. We can now use the same Twitter file to also measure emotionality. We can use the emotionality for each of the data sets. And remember, Condor can export individual data sets. It will give you an aggregated emotionality value, It will give you an aggregated sentiment value. It will also give you an aggregated complexity value, and you can also just count the number of tweets that you got for each of the brands. And so using once more the same Twitter fetch run from before, we can measure who is the most emotional. In this example, Prius is most emotional. The i3 has the highest volume and is also quite emotional. Is most sentimental. So the Chevy Volt sentiment is the highest, and the i3 Prius sentiment is high, and i3 sentiment is high. And the i8 is the most emotional. We can also track emotionality over time, and this also illustrates another effect of Twitter, which has been demonstrated many times, that the volume of tweeting actually goes down over the weekends and is higher during the weekdays, because during the weekdays people just retweet, and on weekends people send out original tweets. And that's why we see this pattern with emotionality going down on the weekends, and during the weekdays we just have a high volume of most emotional tweets, but the difference among those tweets is much smaller. So it's the same tweet that just has been retweeted by different people. But we again see that this fat black line for the i8 is usually at the top, which shows that the i8 has been most emotional in the US. We can also construct the Twitter map. This here is a more nicely version of the same Twitter map that Condor gives you automatically. Here we just have it colored and redrawn manually, and it shows you what people are saying at certain areas, what the keywords are that they are tweeting about. Now we switch from Twitter to blogs. We run the same queries using the blog fetcher, and the network looks somewhat different than it looks from Twitter. This is because now the center of the graph of each network is the search term, and then the actors that are one level apart, one level away from the search term, they are the search results, and then the actors that are 2 levels away from the search term, that point back to the search term, they are the websites linking back to the search hits. And this is what we call the degree of separation search. And if we combine multiple degree of separation searches for each of the different car brands, so here again we have the Prius, the BMW, the Chevy Volt, the BMW i3, Porsche 918, and so on, we can measure how important they are in the blogosphere. And so we see, for example, that BMW i3 has a 17% mind share, Chevy Volt has a 16% mind share, and so on. Again, exactly the same process as we have been using for measuring the strength of a brand in a Twitter sphere can also be applied for measuring the strength of a brand in the blogosphere. And again, we can also measure the importance over time, as we could have measured importance over time for Twitter. Condor offers you the option to export betweenness centrality of all actors over time. And in this case, we just take the betweenness centrality of the search terms over time and show how important they are at any point in time. And that leads to this curve here, where we see that the black line from BMW i3 usually is the topmost line, so it's the most active one. And then we see that the Porsche 918 comes. There is also this spike in the middle around November 23rd. This is around the Detroit Motor Show, when journalists published a lot of articles about cars, which led to a reshuffling of priority ranking among the different brands. And this is reflected very nicely in this blogosphere analysis. We can again use the same blog fetch to measure the importance of the individual blogs. And we see that autoblog.com is the most important one with a bitwiness of 0.08, followed by Engadget and Jalopnik. And again, the conclusion is that the most important blogs are from journalists and newspapers. And we have to go down quite far to find blogs written by non-journalists, by ordinary people. The next information sphere we can analyze the swarm, consisting of online forums, Facebook and Wikipedia. First, let's look at Wikipedia. So here we have searched for those 4 search terms for Toyota Prius, Tesla, Porsche 918 and BMW i3. And we have started with this search term, which led us to the product page of each car brand on Wikipedia. And then we looked at the network originating from that page by following the links on that page. Whenever there was a link on a text page, we included the destination of that link, and then we checked whether the destination page would link back to the original page. And only if we get the backlink, which we call a bidirectional link, did we include it. The reason being that otherwise that network would be far too complex. What we see here, Tesla and Porsche are far more emotional than BMW and Toyota, because their networks are much more linked. And remember, having a well-linked network, and the metric of connectivity is called the clustering coefficient, and it basically measures triads, which means 3 node networks where every node is connected with every node among the 3 nodes. And the more of those triads you have, the higher the clustering coefficient, and the higher the clustering coefficient, the more emotional the group creating the links. And Tesla and Porsche have a very high clustering coefficient, whereas BMW and Toyota are really quite sparse. Facebook is extremely insightful if we get the content. Normally we don't. If we just use the Google Search API to collect data, we get very low quality results. We do the same degree of separation search, restricting our search only to Facebook instead of the entire web, and we get this very sparse network that you see here. And if we look at the word cloud as generated by Condor, we see that the words are not particularly interesting. So while sometimes we might get some interesting insight, the insight is not very deep. But if we get the Facebook group of a product which is maintained by a real community, we get extremely interesting insights. The example that we see here, where we have the BMW Active E and BMW i3 Facebook groups. There is also a BMW Mini Facebook group. We see, for example, that Tom is the most influential person, and his betweenness is quite central. It oscillates over time, so he shows all the characteristics of a lead user, of an influential, of somebody who is pushing and coming up with new ideas in his community. So he's a trendsetter. And looking at the inner side of a community is the best way to find those trendsetters. And Facebook is an excellent way of getting such insights, but we need the collaboration of the community. In this case, we did the project together with BMW to analyze such communities. Here we have another example where we looked at the most influential people in the world. This is a project that we have been doing for the last 3 years with GDI, the Gottlieb Duttweiler Institute in Switzerland, where we collected the most influential people in the world by doing what is called the Delphi process, which means you basically ask a person, who do you think are the most influential people? And we asked some of those thought leaders to nominate others, and then we took their names and we constructed 3 networks. We constructed a Wikipedia network, a blog network, and a Twitter network. And what you see here is the Wikipedia network of 2014. We could also look at 2013 and 2012. And what we see here is that Al Gore is quite central, Noam Chomsky is quite central, and the most central person hidden here behind Pope Francis and Tim Berners-Lee and Amartya Sen are those 3 people. And the network is basically constructed by taking the Wikipedia pages of those people and combining them. So we run a query for each of their 300 people, for the names of those 300 people, and then we combine that network, and then we measure the betweenness of the people, and that's how we can know who the most influential people are. This is the Twitter network. The Twitter, remember, has different criteria. So quite a few of those thought leaders don't even tweet. Pope Francis, for example, he tweets, or somebody tweets for him, and he has millions of followers. And I think he follows only 5 other people, and those 5 other people are himself in other languages. So the Pope knows everything. No need to follow anybody in Twitter except himself. And on a side note, last time I checked, the Dalai Lama was following nobody. Either way, looking at those Twitter networks, and basically we construct the networks here by taking the tweets and then checking at the retweet rate, so meaning looking how many times a tweet by any of those thought leaders has been retweeted, gives us a metric for their importance in the Twitter sphere. So we can see that Fethullah Gulen is quite important, that a Twitter user named Children of Gaza is important, and so on. This here is the same network in the blogosphere, and as with the other 2 networks, the interesting thing is that while we take the names of those thought leaders, as a side product, we also get the most influential blogs and websites promoting those people. So we see that Slate.com is very important. We would see that TED is very important. We would see that the Huffington Post is important. We would see that Business Insider is important. So newspapers, journalists are essential for promoting the fame of those thought leaders. Their betweenness in the blog network is higher than the betweenness of the thought leaders themselves. And here you see the URL of an article talking about that project. Here you see how degree of separation search works. And I have taken my own name here, and I search using Condor, and I get, and you can easily replicate that by entering any query, for example my own name, websites like swarmcreativityblogspot.com, which is my blog. ickn.org, you get LinkedIn, you get oxfordscholarship.com, you get the Business Innovation Factory, which contains a link, a search hit among the top 10 or top 20, and those are the nodes which have 1 degree of separation to the search term which is Peter A. Glor. Then we get the websites, those are the little red dots that are pointing back to the search hits, and these websites have been extracted by running a link colon query. That means we just take the most highly ranked websites that link back to the search hits, to the search results for the search term. And measuring the betweenness of those websites will tell us how important they are. Measuring the betweenness of the search term, Peter A. Glor will measure how important Peter is. We can also use the word cloud content analysis feature to see with what words a search term is associated. In this case, I have taken the snippets that have been automatically collected when I did a blog search for Peter A. Glor, and have used Condor to calculate the word cloud, and we see the most important words that are associated with my name, which more or less describes what I'm doing. We also see how negative or positive they are, and at least Condor seems to think that computer science is not so positive, whereas university and information is quite positive. We can then use that insight to measure the importance of the brand. So here I have taken the degree of separation search for Peter A. Glor and have combined it with 3 people which are much more famous than myself, and have combined the network and measured the betweenness, and that's the process that we have applied to measure importance of the thought leaders in the GDI project I have been mentioning before. So we see that John Kleinberg has here the highest betweenness because he is linked by the most central websites, which are probably Wikipedia, Archive, YouTube, because they have some TED videos on there, and so on. We can also embed the search results that we have obtained by doing individual search into a pre-fabricated baseline database. In this case, I take the thought leader database that I have shown before from GDI, and I paste the search results that I got by running a Condor blog search with my own name, and that allows me then to measure how important Peter is compared to the rest of the thought leaders. So here we see a zoom in, and that will also tell me with what thought leaders I'm most closely associated, and this comes from being mentioned on the same websites and blogs. That allows me then to measure importance, but of course I'm comparing here apple and bananas because I take the thought leader network and then at another point in time I'm just pasting my own network in that pre-calculated thought leader network. If I wanted to do that 100% accurate, I would have to repeat the entire collection process. And here I'm doing the same process with John Kleinberg, and again I see then with what thought leaders he is most associated, which thought leaders are doing similar things as John Kleinberg is doing, and his importance. So he's a pretty important guy. We can also do the same thing in Twitter. And now, because I'm a very passive Twitterer, you see the light blue tweets in the lower left corner, very few of them. So I'm not connected to the tweets of the other thought leaders. and I'm also not retweeted, so this sadly tells me that I'm not a very important person in the Twitter sphere. We can do cool hunting for brands, for causes, for diseases, for products. Here we see an example looking for latest trends on cystic fibrosis, where we looked at what people were saying on the cystic fibrosis forum. We looked on the open Facebook pages about cystic fibrosis, and we looked on Twitter, what people were tweeting about cystic fibrosis. In the forum, we constructed here a network which has two types of actors: forum posts and people responding to a post. We can easily identify the most influential people and the most influential posts. And if we just keep the people, we see that they are surprisingly unconnected on the forum. And by the way, we construct a link between the posts if people respond to an initial thread. And we also see that in the cystic fibrosis forum, the discussion is a lot about pregnancy, and it's all red. So that means it's a very negative discussion. We have repeated that also for diabetes and for Crohn's, and have compared Facebook groups and looked at how active people were on those groups. And we can see, for example, that in cystic fibrosis we have 4,000 actors with 5,000 messages. In type 1 diabetes we have almost 4,000 actors with 9,000 messages, so they are much more active on Facebook. And in Crohn's we have 6,000 actors with 9,000 messages. So what we can tell here is that diabetes Facebook users are more active than others in actually posting. But then we can also look at the likes, and then suddenly cystic fibrosis attracts the most likes with 188,000 for the Cystic Fibrosis Foundation. And type 1 diabetes has much less likes. So that tells us people are very active, but they are not really liking their posts so much. Here we have connected the different networks, and the connections come here through Facebook IDs. And so we see that there are people that post on the groups of diabetes, of Crohn's, and of cystic fibrosis. Otherwise we wouldn't get connecting lines here. And we can also see that people that post on Facebook about cystic fibrosis are more positive than people that post about diabetes. They are the most negative. The emotionality of Crohn's, on the other hand, is the highest. And we can also see how centralized a network is. And we see that the Crohn's network is the least centralized, which means it's the most scattered, which means it's the least connected. So that means the cohesiveness among Crohn's patients is not very strong. The cohesiveness among type 1 diabetes Facebook pages is much stronger. Here we see a Facebook network of the Cystic Fibrosis Queensland group, which is an open Facebook group. And we can see here that it's quite positive, and they are saying nice things to each other, but not very personalized. If we remove all the peripheral nodes and the unconnected people, the story changes very much, and it becomes very personalized, and people are now starting to talk with each other. So what we see here, we get a lot of unconnected clusters, but they are not yet connected to each other. So we think what can be done here is connect them.